Good morning. Today we will be dealing with fixed orthodontic appliances. Fixed orthodontic appliances are devices that are attached to the teeth and cannot be removed by the patient and are capable of causing tooth movement, unlike removable appliances which can be removed by the patient. There are different types of fixed orthodontic appliance system which we'll deal with later on. Coming to indications, fixed orthodontic appliances are used when precise tooth movements are required, when correction of mild to moderate skeletal discrepancies are required, when we need intrusion or extrusion of teeth, for rotation correction, for overbite and overjet correction, when multiple tooth movements are required, that is, if we need to correct overjet along with rotation correction and overbite correction, everything, multiple tooth movements can be done at a time with fixed orthodontic appliance system. Then for active pro-show spaces. Coming to advantages, various tooth movements can be done at a time, as I said. Grossly misplaced teeth can be corrected using fixed orthodontic appliances. Space closure following extractions can be done. We can establish proper occlusion by correcting crown as well as root position through fixed orthodontic appliances. Precise control over the forces there, and extraoral forces too can be delivered effectively with fixed orthodontic appliances. Coming to disadvantages, it is complex and requires special training. The chair stay time is too long. The maintenance of good oral hygiene is difficult. The rate of tooth movement depends on individual's biological response. Patient cooperation is required for wearing of elastics, headgear, etc. Treatment effects are restricted to dentoalveolar structure. Major skeletal problems cannot be treated. It is aesthetically less pleasing when compared to removable appliances. There is chance of frequent breakage. It is expensive and treatment duration is long. Now coming to evolution. First, there was the E-arch appliance by Edward Hartley Ankle, where molars were banded and a heavy arch wire with threaded bands were ligated to each teeth. But the problem was with each appointment, according to the new position of the teeth, it had to be the ligature threads had to be religated according to the new position. And it delivered heavy interrupted force and it was capable only of tipping tooth movement. So that led to the evolution of the next appliance, that is pin and tube, where bands were placed on all teeth with a vertical tube on each tooth. A soldered pin from this arch wire was inserted into the tube of these bands. Theoretically, it was capable of great precision, but yet it was impractical in use because according to the new position in each appointment, these pins had to be resoldered into the new position and again reinserted into the bands, into the tube of these bands. Next came the ribbon arch appliance system. This was the first appliance to use a true bracket, and here it had a vertical rectangular slot. A ribbon arch wire of gold wire was used. It had good spring qualities and it had showed efficient alignment. But then it had poor control of root position and tipping. So that again led to the next appliance system, that is edgewise appliance, which was a non-programmed appliance. That is the wire bendings, that is first order, second order and third order wire bendings had to be incorporated into the arch wire. First order bending bends are in-out bends. Second order is the mesiodistal bends and third order is the talking bends. So all these bends had to be incorporated in the arch wire. Hence, again, it took a lot of time, chairside time. So next came the Begg appliance system. This was found by Raymond Begg. He was first the follower of Ankle's non-extraction, but later on he found that extraction is required for providing good facial aesthetics. And here he turned the bracket upside down so it pointed gingivally and added auxiliary springs were there to control root position. And this was based on use of light forces and tipping teeth. It had three stages, stage 1, 2, and 3. In stage 1 was alignment and leveling. Stage 2 was extraction of, space closure of the extraction spaces. And stage 3 is correction of tooth angulation and inclinations. Again, the disadvantages were frequent breakage, lack of precision, oral hygiene difficulties, complexity in finishing, and only tipping tooth movement was there. So That again led to the next appliance, that is the tip edge appliance by Peter Kessling. Here, the diagonally opposite corners of the archway slot was modified or cut, and hence there was more freedom of movement of the wire, and it had the combined benefits of ribbon arch and edgewise appliance. Then came the pre-adjusted edgewise appliance system. This is otherwise known as the straight wire appliance. This was based on 6 keys of Andrews occlusion, and this appliance eliminated the need for wire bending. This first order, second order, and third order wire bending was not required to be placed in these arch wires. It was a programmed appliance. So to compensate for that, tip and torque was incorporated into the brackets. This is the Andrew 6 keys of occlusion. Now coming to the parts of fixed orthodontic appliances, there is active and passive parts. The active parts are arch wire, springs, and elastomerics, that is ligate elastics, separators, e-chains, etc. And passive parts are the brackets, bands, buckle tube, lingual attachment, lock pins, and ligature wires. This is diagram showing the active and passive components of the arch wire of the fixed orthodontic appliance system. Now coming to the brackets. Brackets are attachments on the teeth which hold the arch wire for causing tooth movement. They are classified according to width of the bracket into mesiodistally narrow, that is ribbon arch bracket or Dept bracket, mesiodistally wide, that is edgewise bracket. Then according to slot of bracket, horizontal and vertical slot. Horizontal slot, example edgewise bracket. Vertical slot as in Dept bracket. Then according to size of slot, O18 into O25 and O22 into O25. According to material, it can be classified into metal, plastics, ceramics, and a combination, that is metal with ceramics or metal reinforced plastics. Then according to the ligation method, it can be classified into conventional ligation and self-ligation. Conventional ligation is as shown in the picture using the ligature wire or E-modules. Then self-ligating is they have a locking mechanism in the bracket itself. You don't need a another method of ligation for keeping the archware inside the bracket slot. That locking system is present in the bracket itself. That is self-ligating brackets. Then according to movement of teeth, tipping tooth movement, that is Dept bracket, bodily movement, that is edgewise, both tipping and bodily movement, that is tip edge bracket. Then according to bracket morphology, Siamese, single wing, and mini twin. According to bracket base, there is meshed, then micro lock, dyna lock, etc. According to bracket technique, there is back light wire, edgewise, straight wire, tip edge, pre-adjusted, lingual, etc. Now coming to bands, these are passive components that carry attachments or arch wires are inserted into the tubes of the bands. It comes in as plain where tube has to be, buccal tube has to be welded, and otherwise it comes along with the buccal tube. This is available as preformed or can be custom made. Now, arch wires, they are active components of fixed orthodontic appliance system. This is also available as preformed or custom made. According to material, it can be classified as stainless steel, nickel titanium, alpha titanium, cobalt chromium, aesthetic arch wires. According to shape, it can be round, square, or rectangular. According to size, 012, 014, 016, 018, 16, 22, 17, 25, 18, 25, etc. And for leveling and alignment, night-eye arch wires, hand or coaxial or multi-stranded arch wires are used. For retraction stage, stainless steel arch wires, rectangular stainless steel arch wires are used. And for finishing stage, round stainless steel wire or TMA wires are used. Stainless steel arch wires, it is otherwise known as 18H stainless steel or osmotic stainless steel is used for this purpose. 18% chromium, 8% nickel, 17% iron is present in this arch wire. That is, you have dealt with that in your second year preclinicals. Then next is AJ Wilcock wire. This is used in the bed appliance system. This was found by Australian metallurgist AJ Wilcock. This has round, the wire is round in cross section and is available in various diameters. Braided or twisted arch wires. Here, the stainless steel arch wires of small diameters are twisted or braided to form larger wires of round or rectangular cross section. They are used for initial alignment. LG Loy, that is a originally used by Elgin Watch Company, and it is a cobalt chromium based alloy. This was introduced to orthodontics in mid 1950s, where 40% of cobalt and 20% of chromium was present. Then is the Nite arch wires. This was introduced at the Naval Ordnance Laboratory, hence known as Mitonol. And to orthodontics, it was introduced by William F. Bibler. It had the property of shape memory and supraelasticity. The shape memory is the ability of the material to remember its original shape after being plastically deformed. That is, this shape memory occurs due to the supraelastic property of the alloy. Next is the aesthetic arch wires. There are three types: composite, Optiflex, and coated arch wires. Composite consists of ceramic and acrylic resins. The Optiflex has three layers, that is silicon dioxide core, silicon resin middle layer, and nylon outer layer. Coated arch wires, this is Teflon coated or epoxy coated or nitrile two-toned. Next is elastomerics. They are materials that rapidly return to their original dimension after substantial deformation. It is made of latex elastics, and it can be used for separation of teeth, for placing bands. Those are known as separators. Then closure of spaces, that is pouch chain or E-chain. Treatment of crossbite, that is crossbite elastics. Correction of intra-arch relationship, that is class 2 or class 3 elastics. Correction of intra-arch relationship can be done using class 1 elastics. Derotation of teeth using elastic thread, and engaging arch wire to brackets using modules. Next is elastics. There are intraoral and extraoral elastics. Intraoral elastics, according to diameter, it is again classified as 1 by 8, 3 by 16, 1 by 4, 5 by 16, 3 by 8, according to color: red, blue, green, yellow, pink. Then this can be used for various correction of malocclusion, like box elastics for correction of open bite, for crossbite elastics for correction of crossbite, then inter and intra arch elastics. That is class 1, class 2, class 3 elastics. Then elastomeric chains. These e-chains are of pure polyurethane in nature and are commonly used to generate light continuous force for canine retraction, diastema closure, rotation correction, etc. This can be short or long. They absorb water and saliva and permanently stain. And the force PK is greatest at 3 hours. Lose 50 to 70% of initial force during first few days. After 3 weeks, retain only 30 to 40% of the original force value. Now springs. When springs is asked for exam, you have to write both removable appliances, the springs used in removable appliances and fixed orthodontic appliances. In fixed orthodontic appliances, there are uprighting springs, that is for mainly for uprighting molars. Then rotation springs, correction, that is for correction of rotation. Torquing springs, coil springs, that is both open and closed, open for opening it for space and closed is for closing it for spaces. Night A springs, S springs. Next is separators. Separators are used or placed between molars for creating space to place the bands. It can be metal separators known as Kessling separator or elastic separators as seen in the picture. Then there are lock pins. Lock pins are used along with the beg appliance. This lock pins are used to engage the arch wire in the bracket, the beg's bracket. Okay, so that the arch wire will not come out of the bracket. This will be locked inside. There are three types, that is safety lock pin, hook lock pins, and hi-hat safety lock pin. Safety lock pins is used in stage 1 and 2, and hook lock pins is used in stage 3. And hi-hat safety lock pins is used for engaging elastics. Then coming to bonding, there are two types of bonding, that is direct and indirect. In direct bonding, first we clean the tooth surface. We etch it with 37% orthophosphoric acid for 15 to 20 seconds. Then we wash it off, rinse it with water, and then dry it and isolate it with cotton roll suction and using suction. Then we apply primer and air dry it. Then we place the bracket with the composite. And then the excess flash will be removed and then we cure it. If it is self-cure, it will cure on its own. Okay, this is the diagram showing the self-cure. So this will cure on its own, but light cure will use 470 to in between 450 to 470 nanometer wavelength of light for curing. Mainly LED lights are used. Indirect bonding, first we have to take impression of the patient and then we will bond on the teeth of these casts using the brackets. We transfer these brackets onto a tray, which is used as a template, and then it is placed on the patient's tray along with this brackets is placed on the patient's mouth or patient teeth, and then we cure it. This is a more accurate way of bonding. This was introduced by Silverman and Cohen. Now, once we finish with all these, we have to give instruction to the patient. Okay, that is after doing fixed orthodontic appliance system. The last what we have to do before leaving the patient is we have to give instruction to patient. So, what all instructions will we give? First, they have to brush teeth before and after every meal and before bed. They have to avoid eating hard and sticky food, and then contact orthodontics in case of pain or loose appliances. And regular visits is required. Now, to conclude, the complications associated with the fixed orthodontic appliances is periodontal problems, demineralization, traumatic injuries, iatrogenic injuries, tooth mobility, pain, tooth resorption, loss of tooth vitality, and caries. So all this can accompany fixed orthodontic appliance system if we don't take proper care or if we don't maintain good oral hygiene. Okay, so that comes to the end of fixed orthodontic appliance system. Thank you.